Hi, everyone. Thank you very much for joining this webinar. The topic today is very exciting because I've been receiving a lot of questions from users, most of them with gINT files for their historical data. And they were asking how they can make best use of that data and utilizing it, either bringing it to RSLog or somehow at least bring everything into one single database. So that's a problem that I think many geotechnical and environmental consulting firms are now dealing with. The title is Modernizing Borehole Data Management by Digitizing Your Historical Data. Okay, so my name is Alireza Afkhami. I'm Senior Director at Rocscience and Product Manager of RSLog. I've just prepared this slideshow to go over this topic and offer the features and the solutions that we have for dealing with historical data. I'm sure all of you are familiar with rock science. We started back in 1996 and developed tens of geotechnical tools that are used as leading software solutions at the moment in the market. We have about 100 staff at the moment and expanding very rapidly. I'm sure you're familiar with our slope stability program, rockfall solutions, finite element software, and other programs for pile design, for example, settlement design, and so on. Um, the two programs that recently joined our collection of applications is RS Wall for retaining wall design. Is an absolute wonderful program to use. Make sure that if you're not familiar with it, make sure you download the trial. Same for RS Seismic. I know that a lot of engineers have been waiting for a revolution of site response analysis software, and it's now there. RS Seismic is out. There was seminars or webinars by Dr. Hashash and my colleague that went over the features of RS Seismic. Make sure you watch that webinar and download the trial. Now, RSLog, the first version of RSLog came out in February 2022, and since then, we are routinely developing and updating RSLog. It's a web application. For those of you who are not familiar with it, it's a web application, so you can access your data from anywhere at any time. And we keep adding more and more features to it. In terms of the ecosystem of our software products, programs talk to each other, which means you can send data from one program to another program. You see this diagram describing that connection and integration. When it comes to RSLog, RSLog is integrated with Slide 2, Settle Tree, and RS Seismic. And that means if you have your borehole data in RSLog, then you can just send that data directly to these programs. More integrations will be added in 2026. Now, when we look at the workflow of a geotechnical or environmental project, almost always we start with a desktop study. We always want to go back to our historical data and see what we have in that area for multiple reasons, but mainly in order to minimize the cost and also to minimize the risk. So first thing we do, we always go back to our GIS system or to our network, whatever system that we have for handling our historical data set. And then once we know how much data we have in that area, we set up field investigation or prepare our proposal. If we get the project, go to field investigation, do some lab test, and do the design and reporting, and eventually going to construction reviews. Anything from desktop study to reporting, RSLog can help you with different features that we've designed. Um, anything from historical data set to borehole logging to project summary report, to importing the lab test results, generating borehole logs, and all that. And then, of course, if you need more design and analysis, you can use other Rocscience applications for that purpose. The focus of this presentation is about significance of historical boreholes. So the first reason that we need um, to organize our historical data is that we want to minimize the cost. So if you know that you have 5 borehole across the street from here, then in that case, you may want to reduce the number of boreholes for this new project because you're already familiar with the site, right? So it's a very efficient way to save time and money and still get the subsurface data. And the second one is that if you want to do some preliminary or feasibility study, in a lot of these cases, the money is tight, the budget is tight, and if you have any previous data, it's going to help a lot, and it actually will put you compared to other consultants in a much better position. And of course, by knowing the problems on that side, you can minimize the risks. Like if you know that this is a site with peat, or this is a site that will need piles or liquefaction is going to be a problem, then definitely you will take that into consideration in your design and in your study. Also about variability of soil properties across the site. Again, if in your city, in your area of practice, you have lots of data and there are companies with thousands of projects in just the city that they're mainly working in, and being able to organize that data and access that data in an efficient way will help them to look at the effect of topography or subsurface data, variation of it across the plan. And of course, you can then get that data, like run queries into that data and get the variation of your SPT data or CPT processing or soil classification across a large area. As these are some of the major reasons that you may want to bring all your historical data in one single database. Like with gINT, most of most of the most of companies that utilize gINT, they had a separate gINT file for each project, which was a problem because there was no way to bring all the data into one central single database. We've come up with a very good solution for that I'm going to talk about here. Now, the first step is to take a look at different formats of historical data. So historical data, like for really old data, they are in PDF format. So like boreholes from 1980s, 1990s, you have only paper log. So the best we can do is to just scan them into PDF. There are also sometimes projects that you're working for a client and you know that the project or maybe a previous phase of that project was done 10 years ago. So there should be some sort of digital, like a database for that borehole data, but you don't have access to, right? Or it's going to take a lot of time in order to obtain that data. So in that case, you will have only the borehole logs in PDF format. Another common format is the spreadsheet format. So in many cases, you can export from a software into CSV format, or maybe, I mean, I've seen certainly companies switching from Excel borehole logging to RSLog. I mean, I've seen that. So some companies are still using Excel for storing their borehole data. So in that case, it could be easily exported to CSV. And of course, geotechnical software such as gINT, Strater, Geosystem, these are one of the very common type of database applications for borehole logging. We have some data exchange formats such as DIGS and AGS. DIGS standard file format is mostly used in the US. It was created by GeoInstitute and used mainly right now by Department of Transportation's as a common data format for data exchange. AGS was created by British Geological Survey and is mostly used in the UK, Australia, Hong Kong, and a few other countries. This is generally XML file. AGS is generally CSV file, but it carries different blocks of data. And your data may be in other database format, like it could be SQL Server, it could be Microsoft Access, it could be any other database. If you are using anything other than the programs that we mentioned, so there are ways to get we have to find a way to get your data out from those databases and get them into RSLog. In many cases, companies worked over time and put their data into a GIS application. And in these cases, it's mainly about the location of the projects and boreholes rather than being the actual detailed data. Like in the company that I used to work as a senior geotechnical engineer before joining Rocscience in 2021, that company had locally over 4,500 projects. And over time, we had put those project locations on a Google Earth file and a KMZ file. But it was just the borehole location and maybe just project name and project project number. And we were able to just get the project number and go to the folder on the network. So that was sufficient for the purpose of going back and checking how much data we have in a certain location in the vicinity of that project location. Many companies have done it. And if you are one of those, I have good news for you. You can easily bring this data into RSLog. In some cases, the borehole data is in DXF or DWG or MicroStation format. There are companies or DOTs that they include like the stick log of their boreholes into construction drawings, right? So there might be even no borehole log, just that stick log in DXF format. So that's another source of data that needs to be dealt with. And of course, we've come across some software applications that store data in text file. One example is WinCore software that was created by, to the best of my knowledge, by Texas DOT back in 2000s, and it stores data in CLG files, but it's actually a text file. So that's another challenge in order to bring data. We also have good news for WinCore users. But the first step in starting to bring your data is always to decide what you want to bring to RSLog. What do you want to bring to that centralized database? Do you want to just bring the locations, or you want to bring the detailed borehole data, right? And this is one of the most important decisions that you do at the time of data migration, because option 2 is going to take a lot more resources from you and will be more challenging because you may have data in different formats. It's not just one format. And even that specific format, say, if you have all your data in PDF, say, so those PDF files, not all of them have the same log template, right? Maybe you evolved your log template design over time, and now you have like 5 different log templates that are slightly different. or maybe for different projects, you have different log template, right? But if you want to bring just the location of boreholes or projects, it's going to be a lot more easier. In RSLog, you can bring either GIS applications or you can bring CSV. Now, importing locations to RSLog, as I mentioned, is super easy. Doesn't matter if you want to bring the location of the boreholes or if you want to bring the location of your project. Doesn't matter. For RSLog, or the way that RSLog is going to display it on the GIS map is essentially as a point on the map. And in terms of formats, we cover different GIS formats as well as CSV. And many companies that we work with, they have actually that data in an Excel file. So it's very easy to get that data in CSV format, right? In this example, in this screenshot, you see that we imported 2000 historical data as CSV. So here under new, if you click this arrow button, you can import from CSV. And the only thing you need is just a title for that data point. You can add client name, project number, and address if you have it or if you want to share it on the map. But you will need coordinates like latitude, longitude for that point. You can even add an external URL for each of those data points. If you have civic address, like assuming that you want to bring the project locations, if you have an actual civic address for that project, good news is if you don't have their latitude, longitude already, RSLog will take care of that. So we convert those addresses to latitude, longitude, and then put them on the map for you. You see in this screenshot, this data is imported, and now on the map you can see the project title and its location, and even the external link here. That external link is actually very useful because you can use it to jump to the project folder, for example, or you can use it to go to a certain page on your local network, right? So bringing data in CSV format is super easy. If it's in other format, most commonly in KMZ format, again, you just import that KMZ in RSLog on the GIS page, and those locations will be showing here on the map. You can turn on contours and geology maps and stuff. It's a very powerful GIS map that helps you bring all your data at one location. You can even search for a specific project and so on. Importing detailed borehole data into RSLog, it is a bit more challenging because you have to deal with a number of issues or challenges and organizing data and using different tools. The most common format for all data for all their type of projects is obviously PDF format. And for that purpose, we have a feature called OCR in RSLog, which is a premium feature, but it's definitely much more efficient than trying to do the data migration or extracting data from PDF manually. It's almost impossible to do that. But with OCR feature, the only thing you need to do, you need to scan those pages, and then you will upload them into RSLog using that feature. And once the data is uploaded, then they will go into a lineup, into a queue, and the file will be processed. And then in the next step, you'll have the chance to essentially finalize the log template, right? Because that's the whole thing. Like, you need to tell the program, here's my header, here's the footer. The program will identify and detect these and automatically, but you will have the chance to finalize. Just make sure that header and footer is properly detected, and then the next step is to just confirm that, okay, here is my project number in this area of the of the PDF in the header. Here is my project address or borehole depths, and then of course dealing with borehole log columns. Okay, this column carries literature description. This column is maybe moisture content, test results, and so on. Once you finalize this, we are going to save that template in your RSLog account. So in the future, if we upload another a PDF that follows the same log template design, we are going to automatically detect it, and you don't you don't need any more work on this template design page. And what happens is the data will be automatically imported, the extraction will be done, and if you have coordinates on these borehole logs, they are going to be immediately on the GIS page or on the GIS system, GIS map in RSLog. Another feature we have, which I guess most of you um, will be using it, is the gINT import tool. Many of our historical data is in gINT format. The gINT import tool, the way it works is that, like, I've been personally a gINT user for about 17 years, and my colleagues and our customers have a lot more experience as well. So we use this collective experience of using gINT. And what we did at the time that you upload your gINT file, we go through the data structure of your gINT into your gINT database, and we automatically detect um, where to get each piece of data. One big advantage of gINT at the time was flexibility of its data structure, in a sense that if you knew how to tweak gINT design, you would go into the database design. gINT uses Microsoft Access database. You would open it in Microsoft Access and then add maybe columns to this table, or maybe add a complete new table and store your, say, drilling observation, for example, in this one. You want a separate table to carry that data. So you could do that. Now, the challenge for any other software now to import from gINT is to be flexible enough to map with that flexible, unexpected kind of data structure. And that's what we created here. User will be able to map their project data, map their borehole data, and then go through every single of these tabs, like for sample and stratigraphy and field tests and so on, just to make sure that everything is properly mapped. So the main challenge is where to find each data. Like, as an example, like driller name, like if you store driller name in your gINT file, we need to know where to get that data, right? A lot of these will be automatically set by RSLog, but if you see something is missing, like you collect air temperature, but we don't know where to find it in your gINT file, you can just come here, open this drop down, and say, here's air temperature, right? The good news is we save this mapping for you. So this stays in your gINT file, and next time you upload a gINT file, we'll automatically set the same mapping for you. You can even download using these buttons. You can download the mapping. You can upload a specific mapping if you have more than one different gINT data structure. So once you do the mapping for your gINT file, it may take like, I don't know, 15 minutes, 20 minutes, depending on complexity of your gINT file. Then you click import data. We extract data from your gINT. Doesn't matter if it's 200 boreholes or 5 boreholes. We do that, and then we notify you when the project is completely imported, so that in the meanwhile, you can still use other features in RSLog. And again, like I said in the previous slide, if your boreholes have coordinate, we are going to handle that, and we're going to put the borehole on the GIS page. We handle different types of coordinate system, from geographic, UTM, from a state plane coordinate, all those EPSG codes. If you're outside North America and use those EPSG coordinate reference system codes, we handle all of those. Even the coordinate system, geographic coordinate system, if it's in degree, minute, second, we combine them, turn them into decimal, latitude, longitude, and use them. Like a stratigraphy is another one in this screenshot. Like, some companies have only one table in their gINT file that handles stratigraphy data for soil and rock, like in the same table. But some other companies have separate tables for soil and for rock. So now, with the latest version of our gINT import tool, you have the chance to indicate that you have two different tables and deal with them separately. Very detailed, very powerful gINT import tool. Now, Dix is very simple because RSLog is fully Dix compliant. We import from Dix and we export to Dix. We are very active in participating in all GeoInstitute Dix meetings on a monthly basis. For AGS, at the moment we have a Excel add-in for loading and editing AGS. What we are working on, which I'm hoping that will be released in January 2026, we are working on an AGS editor feature that is built into RSLog. So soon, in order to handle the AGS data, you don't need to do anything outside, no Excel add-in or things like that. You will be able to simply, and this is a screenshot of that feature under development, you will be able to just simply import the AGS, and we just automatically detect your data in different groups. Different tabs here are different groups in that AGS file. And then here you will be able to just edit that very easily in a spreadsheet format. Just with the arrow keys, you can go make changes. You can open drop downs by pressing enter and just select the options. AGS 4.1 is supported. AGS dictionary is completely implemented. Even user defined columns and groups are included in our AGS feature. If you use AGS and you're expecting a feature like this in RSLog, please contact us and we'll be happy to give you early access so that you can run some tests on your end and provide feedback. We really appreciate it. And once your edit of AGS data is done, then you will be able to export that data to AGS. Now, phase 2 of this will be to link this AGS feature to integrate it essentially with cross-section designer, for example, in RSLog, to the query builder feature or to other features, so that you can take advantage of all the advanced tools that we have in RSLog. Now, when it comes to other databases, remember I said you may be using not gINT, maybe another a software for borehole logging and borehole data management. They may have Microsoft Access database, SQL Server database, or any other database. I would say if it's Microsoft Access, try our gINT import tool, because gINT is also Microsoft Access database, so there is a good chance that the gINT import tool can help you with importing data. But there is always the solution of exporting data from your database to CSV and then importing it into RSLog. We have a very powerful CSV bulk import feature that helps you save a ton of time when it comes to importing from CSV. I'm going to go through that CSV import in the next slides. The same for SQL Server. You can either export to CSV and import it. In fact, we are working with one of the large companies right now to import their data to RSLog with CSV, or you can use our API functions. If you're comfortable with doing some programming, then you can use RSLog APIs. I'm going to talk more about that. Like a Strater, for example, from Golden Software, we have many users, many companies that have been using a Strater in the past many years, and now they want to bring that data. The easiest way for a Strater is to just use CSV. Their database format is not easy to crack and bring the data to RSLog that way. So CSV is your friend if you want to bring data from any other type of database formats. And of course, WinCore. So WinCore, as I mentioned, was created by Texas DOT. We have many consulting firms in the state of Texas that have a ton of WinCore data, CLG files. The good news is we have a built-in CLG import, like a bulk import type of feature. With that, you can like upload 50 CLG files at a time. And what we do, we just extract data from each individual CLG and create its borehole, create the project, add boreholes to that. It's very efficient and it's very easy to use if you have a lot of WinCore historical data sets. Now, the bulk CSV import, this feature, we added it back in, I think, March of 2025. We always had CSV import in RSLog, but imagine if you're bringing your data for hundreds of or even tens of boreholes in a project, you don't want to export the data of each individual borehole as a CSV file and then import it to RSLog, because if you have 50 boreholes, that means you will have 50 CSV for sample data, 50 CSV for SPT data, and so on. It becomes impractical to bring data. So what we did with the bulk CSV import, we offer a feature that you can stick to creating only one file. For example, when it comes to sample data, you can see in this screenshot, this is sample data, like sample depths from and to, and then sample number, sample type, recovery, and so on. But these are not just for one borehole. So the magic here is that you can have a single CSV file. You just add a column to it for borehole name. You see, this is BH4 up to this point, and then BH5, and then it starts BH6, right? So all of your sample data for the entire project is in one single CSV file, right? So if you have that feature, if you have that data exported properly and in this format, doesn't matter the order of the columns or the column header text, none of this matters because we are going to take care of that part. The only thing you need to do, you need to generate or export the list of boreholes in a CSV, and you need like borehole name, borehole depth, coordinates, borehole elevation, any data that you have for a borehole, like hammer, SPT, hammer energy level, or date of drilling and things like that. So that's one CSV. Another CSV list of samples, another one for list of SPTs, another one list of the strato data. And what you do, you start by importing the list of boreholes. By doing that, RSLog creates all those boreholes, but the boreholes will be empty, right? Then you just open one of those boreholes and go to, for example, sample table, and import or upload your CSV file that carries sample data, okay? And the only thing you need to do here is to map the columns of your CSV file to RSLog data entry columns. And that's what we have done here. You see, like here, sample NO is sample number, right? So we map these two. Like these are clear. I mean, these are easy, right? But even if your column header text is different, you can easily map it to the right data entry. And you see that I've indicated my first column in the CSV to be the test hole name and selected this checkbox. So now the program knows which record belongs to which borehole, and we take care of all the heavy lifting that comes with importing that data. Now, one case history here to share with you, one good example is the Crossrail project, Elizabeth Line project in London, UK. So this is a real project with more than 1,800 boreholes, 61,000 samples, about 10,000 SPT records, and more than 20,000 strata description. All of these in only 4 CSV files. So just imagine being able to import this volume of data with only 4 CSV imports and in less than 10 minutes, right? So this bulk CSV import is your friend if you want to bring your data and your data is in CSV or can be exported to CSV, right? Now we talked about API integration. This feature, we added this in the past couple of months. And if you know, like, Python programming or C# or any programming language, what you can do, you can just write a program, directly connect to your data source. Doesn't matter what format is that data source. It could be a real relational database, it could be a text file, it could be a CSV file or anything. With your program, you will connect to the data source and read the data, and then just use our API functions, RSLog API functions, to write that data into your RSLog database, right? So if you want to use that feature, we have a full documentation available, and contact us. We are going to go through different functions that we offer for API integration, and we'll be happy to see that your data migration becomes easier and more efficient. So once you import your data into RSLog, doesn't matter whether you want to bring the locations only or you want to bring the detailed data. If they have coordinates, you will see that the data or the borehole locations, project locations, are on the GIS map immediately. We do all the coordinate conversions for you, and then once the data is in there, then you can use those boreholes. Essentially, you bring those boreholes into life. From PDF, it turns into an RSLog digitized data in your database, and then you can use them for cross-section design, right? So you can import them into your new 2025 project for this bridge upgrade project. You can bring those 5 old boreholes into the new phase of a bridge upgrade, and just combine the new and old boreholes and draw the cross section, and go with 3D visualization or other features that are available in RSLog, even integration with other Rocscience programs. Using cross-section design, these are just some 2D and 3D visualizations that become available to you. So once your data is migrated into RSLog, there is absolutely no difference between the data that you manually entered for a new borehole in RSLog for a 2025 project, for example, or a data that belongs to a project back in 1980s. The same data, it will be available to all other features in RSLog. Some tips and recommendations, and this is going to be our last slide. We'll be happy to answer questions after this. But now, the first thing you need to acknowledge is that data migration needs planning. It's a project. It needs attention. It needs resources. But the first question is, how many different file formats do you have? In what formats your data is saved? Is all your data in gINT, or you have some in PDF, some in gINT, and even those in PDF have different log templates, right? Different gINT versions of your database. And then prepare a list of projects that should be imported into RSLog. Analyze data structure of this, and we have a separate slide actually for data structure that I'm going to share with you. That's an important part of the preparation. And then decide what part of data should be brought to RSLog. And by that, I mean, you may have like a detailed data in your data source, but like you just want to bring the lab test results, for example, not the raw data. You don't want to bring CPT data. Maybe you say, I already have nice reports, CPT or CPT data and plots in PDF format. I don't want to bring that data just because it takes more time, right? Or just final N value versus all the details of grow counts for every 6-inch. And then when it comes to execution, run some test imports and then review those imported data to make sure that the data integrity is maintained, nothing is missed in the during the import. And then plan for resources needed, how many staff needed for this, whether you want to involve an engineer, and that in some cases can help the admin staff, and then running the migration. Now, when we talk about understanding and analyzing the data structure, you need to look at the first thing you want to look at is the data-based relationship, which is a relationship between different tables. Is it what type of database you're dealing with? Like this example is from a gINT file, right? So you need to understand the relationship, like sample data is referenced in all lab tests by sample depths, right? So that's something you need to keep into consideration when you are like using APIs, for example, because you have to find that a sample in other tables. Redundancy of data, and I have an example here in AGS data structure. You see that sample data is in SAMP table and also is repeated in other table as well. You may find it unnecessary, but that's the way that AGS data structure is defined. It's not wrong. It's just you need to be aware of it when you're importing data using like CSV format or using API format, for example. RSLog will automatically take care of lots of these steps. And then selecting what to import. This map is an example for a gINT file, and with this color coding, we helped customer to understand what part of data they can import to RSLog, what type of data they don't want to import to they don't need it. Like they don't need it raw data. They just needed the test results, right? So it's always good to analyze the data structure and figure out and decide what part of data you want to bring, and just focus on those pieces of data. Typical challenges in data migration. One is borehole coordinates. Almost everybody has this problem that the coordinates could be in local coordinate, or even absolutely no coordinate, or just stationing. Again, no easting, northing, no latitude, longitude. If you have some sort of coordinate, any type of coordinate, we cover that and we put that on the map. But if it's in stationing or lack of any coordinate system, there is no way to bring it. So many companies actually choose to add the coordinates in advance before importing, just to make sure that they have coordinates and then they import it. And that could be a painful manual process to find the actual coordinates for those boreholes. Sometimes there is missing important data. Like I've seen gINT files that have only raw test readings, like say for Adderbeck limits, but they don't have like the final LL and PL in the gINT file. It's not stored because at like in runtime when they're using gINT, it was calculated. They decided not to save it. Or cleanups during import, like in gINT, for example, it was very common to use these tags for styling and text alignment. But if you keep these when you import data, then all your lithology description can be full of these tags. RSLog will automatically take care of these and do the cleanup for you. And then reference issues, like if you're looking for a sample, like in gINT, for example, there is no like proper foreign key, primary key design for like samples. It's just by combination of a borehole name and sample depths that you can track the sample in lab test results tables, for example. These kind of things, RSLog, gINT import tool will automatically take care. But if you're doing it manually with API and stuff, then it will need definitely more attention from you. We offer free consultation session to go over your data migration and look at your data, the format of your data, and come up with our recommendations for you. Is free of charge. So feel free to contact us if you want to set up that 1-hour meeting. Okay. Thanks very much, everybody, and we'll be in touch. Make sure you get your trial of RSLog if this is the first time you hear about RSLog. Thanks.